Hello children, now going to explain magnetic energy. We already know that magnets exert force on iron objects and other magnets. The energy is stored in a magnet due to which it exerts force on iron objects and other magnets is known as magnetic energy. This form of energy is used for various purposes such as lifting heavy iron objects, magnetic separation of iron objects and in medical purpose also. So now going to show, just see here, this magnet how attract the iron objects. This is the iron nails sprayed over here. Now see how it attracts. You can see all the iron objects attracted towards the magnet. So this property is known as magnetic property. This is a magnetic energy. This form of energy used for various purposes, especially lifting heavy iron objects and in medical purpose also. Medical resonance imaging MRI, a test which utilizes magnetic energy to detect problems like tumors in the patient's body. Okay. Now fourth type of energy is nuclear energy. This energy stored in the nucleus of an atom is known as nuclear energy. Atoms are the tiny particles that make up every object in the universe, and there is enormous energy in the bonds that holds atoms together. When the nucleus of an atom splits or two different nuclei combine together, a large amount of energy is released in the form of heat. This enormous energy can be utilized for generation of electricity. You can see picture in your book. See this one. Nuclear power plants uses nuclear energy for generating electricity. Okay. Now next topic is energy transformation. Energy transformation. In the previous section we have studied about various forms of energy. We have also read that one of energy can be converted into another form. Okay. Light energy of the sun is utilized by plants during the process of photosynthesis and converted into chemical energy. The parts of the engine of an automobile helps convert energy from one form to another. So in this form many examples are there which proves that energy transform or convert into another form. In thermal power plant, then chemical energy of fuels like coal is converted into heat energy, and this heat is used to boil water, and thus the heat energy gets converted into kinetic energy in the form of steam, and the steam moves the shaft of a turbine and gets transformed into chemical energy. Like in solar cell, the light energy gets converted into electrical energy. In electrical bell and loudspeaker, electric energy converted into sound energy. So in this manner many examples are there written in your book. You read, go through it children. You understand how energy transformed from one form to another. In microphone also, sound energy converted into electrical energy. Electromagnet, electric energy converted into magnetic energy. Okay, so many examples are there. Read point wise. Now production of hydroelectricity. How electricity produced by water. This is the picture given in your book. Hydroelectric power plant. In hydroelectric power plant, huge amount of water is stored in dams which are built at a height. As explained before, water at such height possesses potential energy. When water from a height is released, its stored potential energy gets converted into kinetic energy. The kinetic energy of the moving water is then used to move the blades of a turbine, and which then helps in producing electricity. Okay children. How we can conserve energy? The law of conservation energy states that energy can neither be created nor destroyed, but it can convert from one form to another. It cannot be destroyed or neither created nor destroyed, but it can convert one form to another. The other way to state the law is that total energy of a system always conserved. In all the examples of electrical energy is used to run a mixture, it is possible that 70 joule of water is used to do work, and the remaining 30 joule gets converted into sound energy and heat energy. So even though entire 100 joule is not converted into useful work, but the energy has not been destroyed, but other non-useful forms like heat and sound energy. So in electrical energy, when you run a mixture, 70 joule of energy used to do work, and the remaining 30 joule out of 100 joule gets converted into sound and heat energy. Okay. Now let's discuss some examples to understand the law of conservation of energy, which I have already taught in chapter 2, that is motion of a pendulum. You can see the picture. A simple pendulum consists of a small and a heavy mass called bob. This is called bob, which is tied to a thread from a rigid support. When the pendulum is at rest, its position is known as mean position. Children, this is a mean position. From here, if the bob is displayed a little bit on either side, say A or B, known as its extreme position, and released, it's set into a to and fro motion. This motion is known as to and fro. Okay. So here, as the bob continues to oscillate from O to A, then A to O, and O to B, and then B to O. Okay, so on. Its energy gets transformed from kinetic energy to potential energy and vice versa. For example, at points A and B, the bob has only potential energy. In this point, potential energy, and this point, zero kinetic energy. As the bob starts to move from point A to B towards point O, its potential energy starts converting into kinetic energy. Therefore, for points between A and O, the bob has both potential and kinetic energy. On reaching point O, its potential energy becomes zero. This is the mean position, and this position potential energy becomes zero, and the total energy is kinetic. Therefore, there is a continuous transformation of energy taking place in a pendulum as it continues to oscillate. However, at any instant, its total mechanical energy, which is equal to the sum of potential and kinetic energy, remains conserved. So, the pendulum may not oscillate indefinitely. It occurs due to friction of the medium. The energy of the pendulum is dissipated to the molecules of the medium. Okay, understood? Now, second example is roller coaster. Roller coaster, you can see the picture in your book. Similar to the pendulum, examples given already, is the thrilling ride of a roller coaster. Here, when the roller coaster car is at the top of the coaster, suppose one car is here, A point, this is the top position, and point A, it has the maximum potential energy because the energy is stored here. As it starts coming down, slowly, as already I have explained, children, when stored position, that any object which is on the top position, that is the potential energy, stored energy. When it will comes down slowly, it will convert into kinetic energy because it will come in motion. So that is why here top position is its potential energy. Now when it will slowly comes down, starts coming down, its height starts decreasing, and hence its potential energy decreases and kinetic energy increases. Clear? And at the bottommost point of the ride, that is point B, its potential energy becomes zero. This position potential energy is 0, kinetic energy is high, and the kinetic energy become maximum. The process goes on as the car goes on from point B to C, C to D, and so on. And in between points, the potential and kinetic energies keep on interchanging in the entire path. The total mechanical energy means sum of potential plus kinetic energy. Sum of potential and kinetic energy remains conserved. However, some energy gets wasted due to friction. So this is called roller coaster. How potential energy convert into kinetic energy, and then again potential energy, then kinetic energy. Clear, children? And one stone falling object already explained in previous classes. One activity: if you throw a stone from a certain height, the stored energy is stored at the maximum height. When it will throw down, it will slowly convert into kinetic energy. So vertical falling object, see, you can see in picture, a vertical falling ball shows conservation of mechanical energy when the ball is taken to a height h. Assuming point A from the ground, it stored potential energy in it. And initially at point A, the total energy of the ball is equal to the potential energy and kinetic energy is 0. This means at point A, total energy equal to P plus Ke equal to maximum potential energy. When the ball falls from the height h, its potential energy changes to kinetic energy. If the ball falls to point B half the way, this is the half position, half the way means h by 2. So it acquires both kinetic and potential energy. So at point B, height left to reach the ground is h by 2, and at height h by 2, the potential energy is E by 2, and the kinetic energy is also E by 2. So this means total energy is P plus K equal to E by 2 plus E by 2 equal to E. So on reaching the point C, just to reach or strike ground, height is reduced to 0. So the potential energy of the ball is 0, but it acquires the maximum kinetic energy at this position. This means at point C. So total energy is equal to P plus K equal to kinetic energy. So maximum kinetic energy. So we observe that during the vertical free fall of the ball, the total sum of potential energy and kinetic energy remains same at each point of its path, neglecting air friction. So I hope it is clear to you, children, but I want you go through all this topic once again, read by yourself and do the question answer. Okay, 1, 2, 3 is your syllabus. First prepare the question answer. If any doubt, ask in group. Clear?